Hey, good news. We're back with another episode of Armchair Architects, the Azure Enablement series that's an ongoing conversation with Eric and Uli, two of the smartest architects I know. This episode, we're going to talk about edge computing, so join us. Hey, so welcome back to Armchair Architects as part of the Azure Enablement Show with Uli and Eric. I want to talk about something that came up in the last episode, which is edge computing. And I have to admit, like, as buzzworthy as it is, I don't know how I would tell somebody what edge computing is and what it's not. Can either you, Uli, or Eric, like, help me talk about it to other people? Like, what do you say when someone says, what's edge?
Eric, Uli, you always are great with these initial things, and then I go in for Schlimmbesserheit.
All right. So to me, the edge is it's a compute environment, whether it's of different sizes that exist on premises for the purpose of helping customers and helping solutions do things like aggregate, filter, or inference on data that's coming from devices that are connected to that premises environment. So in many instances, there's a spectrum of devices, and we can go from constrained edge devices to data center class edge devices, all with different levels of compute power and complexity and different types of solutions in places where you can host AI models, filtering models, maybe even database components, all in the purpose of doing things in the on-premises world before they actually connect to the cloud and send data to the cloud.
So let me add one capability to this, which is the reason why it's called edge, because what Eric described, you could also do with an on-premise environment of whatever technology you choose. The reason why it's called edge, it's because it's part of something. And it's part of something is called the cloud, meaning it's the edge environment of the cloud, meaning I take the operating model, the control plane, the business model, the technology model, security models, and all this stuff, and transport it or export it from a centralized environment like Azure in its region to a place where you want the solution. It could be an on-premises data center. It could be inside a factory. It could be inside an airplane. It could be inside a Mac, which is effectively a compute environment provided by a telco provider like AT&T or Deutsche Telekom or whoever it might be. And so you effectively have, as Eric said, a compute environment that is independent of an Azure region, but conceptually is linked to that Azure region based upon operating models, business models, technology, security, etc. So an edge is always part of something, and that something is the cloud.
And do I, like, the sort of child in me thinks like, oh, okay, so I go to an Azure data center, I pull some things out of a rack, and I send them places, right? And to a certain extent, I'm extending the cloud by bringing that computing device that would have been centralized out closer, and I'm doing that because there's a lot of chatter on the edges, and if I can process that at the edge, then I don't have to take it over the longer distance or whatever in terms of time or whatever back to the central thing to do the work, because I've already done a bunch of the work. Something else has pre-queued it for me, and that gives me a lot of flexibility. Am I getting it?
Conceptually speaking, you are right. I mean, we don't do it that way because we don't assume that people want to run an Azure rack in their environment, whatever that might be. Right. So what we do is we effectively provide you with a software framework that does potentially have an appliance, a hardware piece like Azure Stack Edge or Azure Stack Hub or capabilities like that. But primarily it's a software piece. And the latest incarnation of our Edge framework is called Azure Arc.
Okay.
And Azure Arc literally extends, for example, the control plane of Azure to capabilities that are outside of Azure, like VMware VMs or Azure Stack VMs or Kubernetes environments from Kubernetes in K8, and down the line we're also planning to support smaller Kubernetes environments like K3s, so that you can effectively take edge environments not just with server class hardware, but also with Raspberry Pis or stuff like that for more complex, richer IoT scenarios where you need high availability of those supporting capabilities for edge processing and so forth. And Eric, David, you already pointed out then there are two use cases that are really paramount for why edge computing is important, or actually three. One, safety. First thing, if a physical device interacts with humans, for example, you cannot afford to go to the cloud. It has to be local, and decision-making has to be instantaneously, because anything that has to do with human or other safety has to be local. The other one is what often is cited as latency. Again, there I'm a little bit on the fence, because latency, especially in the US, for example, to cloud regions is superb. There's very little latency, but sometimes you do need to have round-trip times that are just not achievable if you go over a wide area network. And then the last piece, which you also mentioned, and Eric has, I think, we talked about a lot, is if the data is so massive and it's not relevant for AI development, in general, people keep the data local and process it local. And again, we talked already about the fusion switching, where you have to effectively immediately react, otherwise the batch might be kaput and stuff like that.
The other thing I wanted to bring up here, David, so Uli, you stole my example, so I'm going to actually transition into another topic I wanted to bring up here, is that I can hear people from maybe process manufacturers, discrete manufacturers yelling at us, well, what about like ISA 95 and Purdue networks? What about the difficulty around constrained devices? The edge is so nebulous, I can kind of think about it anywhere, to which I can say, yes, we absolutely need to think about those things when we figure out what types of workloads and solutions we need to run at the edge. We absolutely have to make sure that we can operate in those constrained environments in secured network infrastructure. Sometimes, David, many of the assets that we want to harvest time series data from lives inside of a level 0 in a secure network architecture. They never even see the plant network, let alone the production network, let alone the internet network. And so we have to figure out clever ways of doing things like deploying technologies like nested edge to kind of bubble those things up in a secure and constrained environment.
Yeah, let's step back here a little bit. You threw a whole bunch of concepts at our users here, or our readers. And so an ISA 95 network or Purdue network is originally coming from the chemical industries. And chemical industries, if you do the wrong thing, could lead to blow-ups, because this is dangerous stuff. And therefore, they have a hierarchy of networks from level 0, which is the local control plane that literally manages the mixers, the cookers, and whatnot, and could lead to literally explosions and damage to humans or equipment and so forth. Then you have levels up to 5, is the original Purdue architecture, which is now officially called ISA 95. And there is no way that level 5, which is, let's say, an ERP system running in a back end, goes immediately to level 0, controlling the device. That's just not allowed. And therefore, you have to go and forward commands from level 5 to 4 to 3 to 2 to 1 to 0 kind of thing. And that requires a technology called nesting. And the IoT Edge team delivered a capability called the nested edge. So that allows a edge at level 0 to talk to an edge at level 1, talk to a edge at level 2, etc. And we have built the necessary forwarding and queuing architectures so that commands and data can flow in either direction through gateways effectively that protect the layer 0 from layer 2 and so forth. So that's really what's behind this ISA 95, which is obviously a fairly big deal. And it's very complex, and therefore solutions need to be found, like the IoT Edge does with its nested edge support.
Okay, so I have a follow-up question. I'm assuming, because you said it's an extension of the cloud, that part of that means that we, the cloud provider, promise to be the people in charge of managing, updating, upgrading the thing that you have. Whose job is it to determine how thick that edge is and what capacity I need at the edge? Is that something that architects pay attention to? And can I, because it's a device, don't I lose that, like, I want a bigger device magic that comes with the cloud? How does capacity work, and how does management work in an edge configuration?
In my experience, it's all about what you need to do. So as Uli mentioned, if there are human souls, then you need to actually surface alerts and things of that nature. Then we need to figure out how to best navigate that complex network infrastructure and just bubble up those messages. But then we need to figure out what is the actual workload going to be that facilitates that use case, and what can it run on? Because there are a series of what we call constrained devices. These are whisper thin. I only have maybe 2 megs of ROM and maybe 10 megs of RAM, and these things need to plug into a specific space on the plant floor, to some of those data center-esque type elements in which we're trying to push consistency of compute capabilities to the edge, so we can deploy more complex edge workloads with confidence. So I think it depends, but those are the things it kind of depends on from an architecture perspective. You'll know whether or not, and you should know as an architect, whether or not the edge module that you're trying to push down has the ability to run on a constrained device, or if it should run on a more consistent, more powerful compute piece of infrastructure at the plant.
Well, it looks like you have a last thing to say, so to take us out.
I'm just pointing out that Eric's description is completely correct. There is no one size fits all, but the architect is ideally the person that thinks through sizing, and it also thinks through high availability, reliability. Does the system have to be absolutely 100% up and running? That means it's more complex, which means you need more infrastructure inside the factory or plant. Or if it's not, then you might be able to get away with simpler infrastructure, which also influences your sizing. So from my perspective, edges like cloud solutions are not one size fits all. It depends on what it is, what you're doing with it, what are the criticality. If the system fails, what could happen? Again, we mentioned safety before. So obviously, if it's a safety-oriented process, it better be, it is very mission critical, and it better be highly available and robust. So those are some of the things that, again, come to bear here, even more so than in cloud solutions, often because it's the physical world. As I mentioned before, there could be explosions, costing human lives and damage to equipment and so forth.
Cool. Now I have to admit, you got me thinking about what do you have to think about when building one of these architectures. But we don't have enough time to talk about that and for me to mull over that. I'm going to go do it off camera. I want to thank you, Uli. I want to thank you, Eric, for talking about this and getting my brain running on this topic. And I really appreciate everybody watching this. I hope you'll join us again for another episode of Armchair Architects on the Azure Enablement Show.